Oftentimes you'll be given the algebraic rule for each piece of your piecewise function. Let's take a look at x squared. When x is less than 2, not including 2, the rule is you have an x squared function. When x is exactly 2, your rule is y is 6. And finally, when x is greater than 2, and notice it's not including 2, and x is less than 6, including 6, so less than and equal to, all of the x values between 2 and 6 inclusive will use the rule 10 minus x. So let's evaluate f of 3 algebraically. First we need to find which rule applies when x is 3. Your first rule says that x is less than 2. So we're not using the first rule. The next rule says x is 2. Well, right now x is 3. So we're not going to use the second rule. The last rule says x is greater than 2. Yes, it's true that 3 is greater than 2. We're good so far. And your rule says that x is less than or equal to 6. So yes, 3 is between 2 and 6, so we're going to use the third rule. Now using the third rule, we're going to take the value for x and substitute it in for 10 minus x. So you have 10 minus 3 is 7. So the function at 3 is equal to 7, and you have just solved this algebraically. Let's verify this graphically. When x is 3, 1, 2, 3, your y value is 7. Alright, let's evaluate the function at -1 algebraically. So, -1 is less than 2 is a true statement. So the rule we're going to be using is x squared. So let's evaluate the function at -1 for x squared. -1 quantity squared. Remember, if you're using your graphing calculator, you must enter your parentheses in your -1 in the parentheses. However, you can do this in your head. -1 times -1 is 1. So when x is -1, y is 1. Let's verify that graphically. When x is -1, y is 1. Finally, let's take a look at the function when x is -1.5. If you look at this function graphically, at -1.5, you're going to have to estimate your corresponding y value. In these instances, being able to evaluate your function algebraically is extremely helpful because you'll get an accurate answer instead of an estimate. So, when x is -1.5, it's true that -1.5 is less than 2. We're going to use the first rule. Let's substitute our value of -1.5 in for x. So -1.5 times -1.5 is 2.25. So the function at -1.5 is 2.25.